Ladies and gentlemen, we are currently being recorded, so don't say nothing you don't want the internet to hear. Now, we should feel pretty confident with the use of identifying variables. We should feel at least a little bit confident in picking which law we're going to use. And you notice that each of the four laws that we talked about, Avogadro, Boyle, Charles, Gay-Lussac's, they were always two variables. Combined gas law just includes three. It includes one more. P1 times V1 times T2 equals P2 times V2 times T1. We're using the exact same principles that we picked up last class and what you guys are doing for your warm-up. So, first thing we want to do is that we want to figure out what are variables in our question. A gas has a volume of 28 liters, so I got a volume here of 28 liters. A temperature of 45 degrees Celsius. Darn, I'm going to have to convert that in a second. And an unknown pressure. Has its volume increased, so that's my volume 1, volume 2, to 34 liters. And my temperature increased to 350 degrees Celsius. If I measure the pressure, after the change to B, so P2, 2.0 atmosphere, what was the original pressure? So first thing I want to do is I want to convert my temperatures, my degrees Celsius, into Kelvin. So I do that by 45, so let's push it up. 45 degrees C plus 273, 350 degrees C plus 273. Put my handy dandy calculator. 45 plus 273. Nope. That's that. So 318. And then I have 350 plus 273. 623 Kelvin. All right. So now I have all my variables. So I'm going to take my equation. I'm going to pull that down. Sorry. I don't know why my calculator is being weird and blocking everything. P1 times V1 times T2 equals, let me push this up so you guys see it a little better. P2 times V2 times T1. Which variable am I trying to isolate? P1, V1, T2, P2, V2, T1. I'm trying to isolate P1. How do I get P1 by itself? How do I isolate it? I want to divide both sides by V1 and T2. Just like we were doing with the other questions. I have my overall gas law. I'm going to modify my equation to answer for my missing variable. V1 is 28 liters for both of them. Anything in the numerator and the denominator will cancel each other out. T2, 623 Kelvin. Numerator, denominator, they will cancel each other out. Therefore, my modified equation is P1 equals P2 times V2 times T1 divided by V1 times T2. That's my equation I'm going to use here. Someone knocking at the door? Who's knocking at my door? Fast. Oh. All right. So, now that I have my equation, I have my variables, all I got to do is plug them into my equation. P2, that's 2 atmosphere, 2.0 ATM. V2, that's our 34 liters. Our T1, that's our 318 degrees Kelvin. Divide that by V1, which was 28 liters, times T2, which is 623 degrees Kelvin. Everyone agree how we set that up? Oh. I almost marked myself. All right, so I put my handy calculator. We'll clear all that out there for me. So 2.0 times 34 times 318 equals super big number. I don't like the big number. I'm going to divide that by multiplying my two denominators together. So to help me with that, I'm going to use parentheses. 28 times 263, close parentheses. Enter. I'm going to get 1.2396, and it goes on for a while. Now let's make sure I got the right unit. Just remember, if I have my units in my numerator and my denominator, they will cancel each other out. So my liters cancel each other out. My Kelvin cancel each other out. So it means that my final answer is going to be in atmospheres, which makes sense. I'm solving for P1, right? How many sig figs will my final answer have? 2 or 3? 2. Is the 3 big enough to push the 2 to a 3? Nah, so that means that my final answer is P1 is 1.2 atmosphere. Now, I would recommend, to make your life easier and my life easier when I'm grading your quizzes and tests, is that you circle your final answer. Because sometimes we write kind of big, and then we start running out of space, and we start writing really small, and it's back and forth seesaw emotions that I have when grading some people's paper. If you circle your final answer, it just makes life easier for me. I'd appreciate it, and I'm less likely to take off points from you because I know exactly where you ended up at. If I'm hunting to find out where you stopped, that's not good. That means I can't follow what you did. So that's our combined law. Nothing was changed with our combined law, right? We just added another variable. Nothing crazy. But I want to stress that the laws that we picked up, the 4 laws we picked up yesterday, last class, Avogadro, Boyle, Charles, Gay-Lussac's, and even our combined, these were all changing gas laws. Something was always changing. Either I was putting something more into a balloon, the temperature was changing. There was always something changing. I was comparing 2 things at the same time. So Avogadro, I have either my moles were changing or my volume was changing. For Boyle, that was my pressure and my temperature and my volume. Charles, excuse me, that was my pressure and my temperature. Gay-Lussac's, that was my temperature and my volume. In my combined, I was looking at multiple things. Pressure, volume, and temperature. These were our changing gas laws. Our last one, our ideal gas law, is a steady gas law. I'm only looking at one thing. So I'm looking at number 7. Oh, I'll push this down. There we go. We're going to need that part right there as well. I've seen most of this equation already before. I've seen pressure. I've seen volume. I've seen moles. I haven't seen R before, but I have seen temperature. Our R value is going to be a gas constant. And depending on the units used in my equation, depends on which R unit value I'm going to use. It's either going to be 8.314 liters times kilopascals divided by moles times degrees Kelvin, or 0.0821 liters times atmosphere divided by moles times degrees Kelvin. Either one is going to fit in just the R. It's very important that we understand that there are two possible versions of R that we're going to use. Now, how do I know which R to use? I have to pull that from the question. Notice that my liters are the same, right? My moles are the same. My temperature is the same. What's different is which version of pressure I'm using. These numbers mean the exact same thing. But remember, kilopascals to equal 1 atmosphere is 101.3 kilopascals for 1 atmosphere. So because I changed the unit, I changed the number. So if I'm looking at question number 7, I see if I have 4.00 moles of a gas, so that's my N value, at a pressure of 5.60 atmosphere, and a volume of 12.0 liters, what is the gas's temperature? First thing I do is identify what my variables are. Every question, I always start by what am I working with? So I take my ideal gas law equation, I pose it down, PV equals nRT. What am I trying to isolate? The temperature. How do I isolate the temperature? Divide both sides by nR. Because N and R are on the same side, they cross each other out. Therefore, my modified equation is T equals PV divided by N times R. So now I have all the tools I need to succeed. My question to you is, which R value am I going to use? Am I going to use 8.3 or 0.0821? I'm going to use this one right here, right? So I see atmosphere, atmosphere. Had this been kilopascals, I would have used this number. So if I'm looking at my equation, T equals, for my P, that is 5.60 atmosphere times my volume, which is 12.0 liters, divided by N, which is my 4.00 moles, times my R value, 0.08821 liters times atmosphere, divided by moles, times Kelvin. It's important I'm just not plugging them into my R value. My R value holds all these scientific units. So here I see my atmospheres are getting crossed out. I see my moles are getting crossed out. I'm seeing my liters are getting crossed out, leaving my final answer in Kelvin. If I take my handy dandy calculator again, 5.60 times 12.0, enter. That's my numerators multiplied together. I hit the divide button. Now I'll put everything in parentheses and multiply them together. 4.00 times 0.0821. Close my parentheses. I hit enter. 204.628 blah 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 Kelvin. How many sig figs is going to be my final answer? 3 or 4? 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Remember, leading zeros don't count. Is my 6 big enough to push my 4 to a 5? So my temperature is going to be 205 degrees Kelvin for my final answer. Before I say something, I want to make sure that this is true. I'm not lying to you. I'm very mean. I did that by accident. So, I will tell you this right now. Do I expect you to memorize your R values? No. On a test, on a quiz, I will give you the R values. What you are going to have to be able to do is identify which R value you use to solve your problem. If you got that, you're right as rain. What I will expect you guys to know is the 6 gas law equations. What I will expect from you is that you can manipulate, modify those equations to answer for the missing variable. These are the things I'm definitely going to be looking for. And I want you to set up your questions the same way that we were doing it today. By first, writing out your variables. Step 2, writing out the gas law. Step 3, isolate the unknown variable. And step 4, plug in known variables into your equation. These are the 4 big steps that you got to do. 4 big things I'm looking for. Writing out the variables. Writing out the original gas law. isolating your unknown variable, plugging in your known variables into your equation. Every time that I've shown you a question, I've followed these 4 steps. I don't know what gas law to use until I know what variables I have. I need to write out the law so I know how to manipulate it. Isolate the variable that I'm missing. Solve for my unknown variable. Bingo. 1, 2, 3, 4. Easy steps. This is more than half of what's going to be covered on your test. When I see you next time, we will go over the last thing that we're going to talk about, Unit 9. Dalton's partial gas rules. And all we're going to be doing is a little bit of subtraction. Dalton, in the 1800s, thank goodness he had the easiest one to do. If you can subtract, you can pass this test. If you can isolate a variable, you can pass this test. If you can punch buttons on a calculator and round, you can easily pass this test. This is it. I only need you to focus on identifying those six equations, isolate, being able to figure out which one you need to use, solve for the unknown. There's no reason you could not walk away with the last test of the year with either an easy A or an easy B. Some of us saw stoichiometry as being the easiest. I think gas laws are the easiest, because there's only 6 equations I got to work with, and I don't need to use a fancy little mole map in order to figure out where I'm at. This isn't Google Maps, or what's the one they use for iPhones? Is it? It's just Apple Maps. Is it called Apple Maps? They couldn't get creative with it?
I think it's just
whatever the case may be. I don't have to do all that. All I got to do is know 6 equations and be able to isolate something. You can definitely do this, guys. I have absolute faith in you that you can do this. It's nothing new in what you haven't already done in Algebra 1. Now, we got about 10 minutes left in class. Here's the thing. Out of 10 questions, we did 2 of them together. I want you to keep working on the other 8. If you got 1 of them done, great. You got 2 of them done, great. If you were confused about the first one, you might want to grab your notes from last class, or ask the person sitting next to you what notes that they took last class, so that's why you can pick up on that. If not, I've already posted last class's information. It's online for you. I always try to have the recording for the previous class up before you see me the next time. We walked through the steps. We walked how we wrote the equations. We walked through everything. If you're struggling, I'm staying after school today. More than glad to sit down with you. If you can't stay after school because you got a job, you got family duties, you got this, you got that, I'm not going to press you. Meet me during nest. You here already. Right? Ain't no one leaving after first period, right? Swing on by. I'll be here. More than glad to have you.